Morning, folks. So we'll have a wee look at the second type of calculations in equilibrium. We'll skip the first example, we'll go back to it. It's probably the hardest example in the notes. So we'll do example 2, example 3, and we'll go back to example 1. So in the two types of calculations here, the difference in this is that they give you the value of Kc. So the first type of calculation, you're determining the value of the equilibrium constant Kc, and the second type, they give you the value of Kc. So in this we can see the value of Kc for the reaction as that is 50. So Kc is 50. Calculate the final concentrations of each species if 1 mole of hydrogen and iodine and 1 mole of iodine come to equilibrium at 450 degrees in a 1 litre flask. So this is a decent one because it's a 1 litre flask. One above it, I think it could be a 10 litre flask. So start as you always do. Write down your equation, H2 plus I2, and again all my arrows are wrong, give you 2HI. Write down your layout down the side, so your moles initially, change, moles at equilibrium. So when the rate of the forward reaction equals the rate of the reverse reaction, and then your equilibrium concentration, and that's in moles per litre. That's your square brackets. Draw your wee grid. Then you go to. But if you have any bother on this, let me know. But generally, most people like these sort of calculations, and they're nice marks. And then fill in what you have. So the value of Kc is 50. Calculate the final concentrations of 1 mole. So we're starting off there. 1 mole of hydrogen, 1 mole of iodine. We're starting off with 0 of our products. That's all they've given us. Now, you have to just work in terms of algebra, work in terms of x. So what's your ratio here? It's 1 is to 1 is to 1. What happens to my concentration of the reactants? The reactants, remember, always goes down as they get converted into the products. So my change there is minus x. This is the same ratio, 1 to 1. That's going to be minus x. And then my product, we're making products, so it's a plus. And since it's there's a 2 in front of that, it's going to be plus 2x. Keep working down through it. Moles at equilibrium now is 1 minus x. There's 1 minus x. And there's 2x. And as it's a 1 litre container, it's going to be the exact same. 1 minus x, 1 minus x, and 2x. Now if you're looking at a leaving cert question, they might have told you at the start to write down Kc, the equilibrium constant. So Kc is your products over your reactants. So your Hi squared over H2 times I2. Now you can fill in these values. So our value for Kc, as indicated there, is 50, is equal to the concentration in moles per litre of hydrogen iodide, which is 2x, all to be squared over H2, 1 minus x, times I2, 1 minus x. I didn't bless you with much room, but sure. These will be the grand. So 50, 2x all to be squared, 4x squared, square out the bottom, 1 minus x is minus 2x, plus x squared. And now it's just your algebra. Cross multiply 50 times 1 minus 2x plus x squared is equal to 4x squared. Tidy her up a wee bit. 50 minus 100x plus 50x squared is equal to 4x squared. And it's your rule for end the quadratic. 46x squared. I got the 46, remember? Just brought over the 4x squared becomes a minus. Plus 100x, minus 100x plus 50 is equal to 0. You can simplify that down. I'm just going to go straight into the minus b. So a is equal to 46, b is equal to minus 100, c is equal to 50, minus b plus minus square root b squared minus 4ac all over 2a. Still c here. And throw in the values. Minus 100 plus minus the square root of minus 100 squared minus 4 A is 46, C is 50, all over 2 times 46. So I see your textbook does that slightly differently, but I think since you need to know your quadratics anyway, you're good at maths, you know, there'll be no bother to you. And once you learn this once, it won't leave your head, like you'll be the best at it. So I get 1.39, and this, remember, is my value of x. It's equal to 1.39, and then the other value for my x is 0.78. And you've got to say which answer makes sense. The 1.39 would work for that, but it wouldn't work here. 1 minus x, 1 minus 1.39 means I have a negative concentration, which you can't have. You can have 0, but you can't have minus concentration, so x must be 0.78. And have a wee look at the question. Calculate the final concentrations of each species. So my hydrogen, concentration of my hydrogen in square brackets is denoting moles per litre, is 1 minus 0.78. My iodine is the same, 1 minus 0.78. And my hydrogen iodide is 2 times 0.78. So there we get 0.22 moles per litre. Here we have 0.22 moles per litre, and 2 times 0.78 is 1.56 moles per litre. 1.56 in a big M. So the bit where people might get confused, remember, usually you'll have something to fill in here, and you might have said the moles at equilibrium was 0.3, and then you found the difference, and then the difference you would have doubled it up and added it on for your product. So you're just working with it in terms of x, and the reason you're doing that is that they give you the value of Kc. There's nothing else you can work with. One more one here, and then my times can help, but we'll get that other example done. So if the value Kc for the reaction is 4, so this time they give you the 4, but start as you mean to go on. Write down your equation, CH3COH plus C2H5OH, and by all means pause the video, try this one yourselves. CH3COO, C2H5 plus H2O. And there we can see our acid and alcohol giving us the ester and water. Same layout, moles initially, change, moles at equilibrium, and equilibrium concentration. And that just means, remember, your moles per litre. So, write your wee table that you have. Yeah, maybe in one of the live classes we'll do that other example then. So the value for Kc is 4, we're going to use that. 373 Kelvin, remember 100 degrees Celsius, 10 moles of each. Ethanoic acid and ethanol are allowed to react, so we've got 10 there, 10 there, in a sealed container. How many moles formed? That's all they've given us. So we have 0 moles of product at the start. Our change, the reactants is going to decrease, so it's going to go down x. Remember, the ratio is 1 to 1 to 1 to 1, so your product's going to increase by the same amount, plus x. What have you got at equilibrium? 10 minus x, 10 minus x, x and x. And did they give me a size of a container? No. So we still have 10 minus x, 10 minus x, x and x. Now, tight for space, we'll go up to the top. So your Kc is your products over your reactants. So my products is CH3, COO, C2H5 times H2O, all over my ethanoic acid and my alcohol. Fill in your figures and fill in your Kc, which is equal to 4. So 4 is equal to these two values here, the concentrations of them, x and x, square brackets and moles per litre, over 10 minus x times 10 minus x. tidy that up a wee bit. X times x, x squared, and multiply out those two brackets. 10 by 10 is 100, minus 10x is minus 20x, plus x squared. So this would be higher level only. Cross multiply there. 4 times 100 is 400, minus 80x, plus 4x squared is equal to x squared. Jeez, making this hard to see for you. Tidy that up. We have 3x squared minus 80x plus 400, and then do your minus b again. So we minus b minus 80 plus or minus square root of b squared minus 80 squared minus 4 a c all over 2 times a. Plug that into your calculator then, and when you plug that in your calculator you get x is 20 and x is equal to 6.67. So x equal to 20 and x equal to 6.67. Now they've asked you how many moles of ethanoic acid and ethanol are at equilibrium. So you've got to think of your figures. Can x be 20? Can we have 10 minus 20? No, we can't. We can't have 10 minus 20. So we must take our 6.67, and therefore how many moles respectively at equilibrium and how many moles are formed at equilibrium. So for ethanoic acid and ethanol, sorry for this, ethanoic acid and our ethanol, we have 10 minus 6.67, we have 3.33 moles at equilibrium. And notice the difference they asked for moles at equilibrium. In this case it is the same as our equilibrium concentration, but just in case there was a size of a container, they just asked for the moles at equilibrium. And for these two boys here, we have simply 6.67. Fill in for your x, 6.67. Right.